Okay, let's hope this is working. I got green levels going, so I think we are. So, hello everybody. Welcome back to our Future in Space Hangout. We are back after about a month ago, I guess was the last one we did, and today we are going to be talking about the landing system on the moon. Because back on on April 30th, NASA announced that 3 U.S. companies will develop the human landers that will land astronauts on the moon beginning in 2024 as part of the Artemis program. These human landers are the final piece of the transportation chain that's required for sustainable human exploration of the moon, which includes the Space Launch System rocket, the Orion spacecraft, and the Gateway outpost in lunar orbit. The awardees for NASA's Human Landing System contracts are Blue Origin of Kent, Washington, Dynetics of Huntsville, Alabama, and SpaceX of Hawthorne, California. And these teams have offered 3 distinct lander and mission designs, which will drive a broader range of technology development and ultimately more sustainability for lunar surface access. And we are lucky enough today to have representatives from each of those awardees. And want to point out that our Hangout today is sponsored both by Blue Origin and Dynetics. So thank you both very much for bringing this and making this available to people, because we all want to know what's going to happen when we get to the moon. So let me bring my panel up here. There we are. Okay, so my guest today from Blue Origin, we have John Couluris. He's the Human Landing System Program Manager. Also with me is Robert Wright from Dynetics. He's the Deputy Division Manager of Human Landing System. He's from Dynetics. He is in the upper left there, and John is in the lower panel there, and in the upper right panel is Nicholas Cummings. He's the Director of Civil Aeronautic Space Systems from SpaceX. So welcome everybody. And I think the way we've sort of put forth the format for today is each one of you are going to say a couple of words, things like that, and then we will take some Q&A after all of these. So we're going to start with John from Blue Origin. So yes, tell me what you'd like me to have up while you're talking, John, and you can go ahead.
Sure. If you want to start with the first slide, and I'll just cue you when we move on.
Okay.
Good afternoon, everyone. Great. My name is John Couluris. I'm the program manager for HLS from Blue Origin. I'd like to introduce a national team consisting of Lockheed Martin, Blue Origin, Northrop Grumman, and Draper Laboratories. Our team has been working well over a year together to develop the integrated lander that you'll see here on slide 2, please.
Okay.
It's a 3-element architecture, and I'll go through each of the elements. But you can see all the way to the left is the transfer element that's used for our initial burn out of NRHO, the orbit that we'll be aggregating all the elements together in, and performs our initial descent burn. And then in the middle portion is the descent element built by Blue Origin, and then the ascent element at the rightmost of your screen is built by Lockheed Martin. Could you go to the next slide, please?
Okay, there we go.
So the 4 partners have been working very closely together. As I mentioned, what we are trying to do is take the best of that all the partners bring together to truly build an integrated lander vehicle, and not only meet the goal of landing the first woman and next man on the moon by 2024, but also provide sustainability for future missions. The ascent element built by Lockheed Martin contains a lot of components that will be proven on the Orion vehicle and have a lot of work that has been done in the past. The descent element is built by Blue Origin, and that's the culmination of over 3 years of work that Blue Origin has been performing to build this descent vehicle. And then the transfer element is built by Northrop Grumman, building on their experience both with Cygnus and on their most recent award for Halo as part of the Gateway, building that experience and bringing these portions together. And then when Draper Laboratories is a critical partner as well, providing their GNC expertise of over 50 years and also providing specific avionics for our vehicles. So the plan that we have is we will be landing a demonstrator on the moon in the 2023 timeframe of the descent element using the transfer element as well to prove that technology out. And that will then lead to the 2024 mission. What is key about our design is the three elements allow us a lot of flexibility in launch vehicle selection. So one of the risks we're asked about is what if the launch vehicle is not available? Well, we have the capability of going on a number of different commercial providers. Also, by leveraging the experience that each of our partners brings to that element, that allows three independent efforts to continue in parallel as Blue Origin leads the overall integrated effort. So we can work the integration with launch vehicles as well as with each partner simultaneously. We feel this is one of the fastest paths that we can get to the moon. And what's core about our design is this is the architecture that we are planning to use for 2026 and beyond. It allows us to insert modular upgrades as we need to really provide sustainability for those missions. So thank you very much for having me here today. I'm looking forward to answering your questions and any other feedback you may have.
Awesome. Thank you,
Tony.
Yeah, thanks, John. That'd be great. Robert, you want to go next from Dynetics to talk a little bit about what you guys are doing?
Sure thing. Thank you, Tony.
Yeah.
So on behalf of Dynetics, our parent company Leidos, and our lander team, just want to say that again, we're thrilled to be selected by NASA to enable the return of American astronauts to the surface of the moon. I want to thank AAS for planning and for the discussion today and inviting Dynetics to join. We're certainly happy to do that and talk about our human landing system. Our approach features a crew-centric design that facilitates crew access to the lunar surface. And in one of the graphics, Tony, that we had provided shows our lander on the surface that you can maybe pull up and show everyone online. Thank you.
Mm-hmm.
And so you can see the low-slung crew module there and the ease of access for the astronauts to get from the crew module to the surface of the moon. We provided in our approach an innovative two-element architecture, which reduces the number of highly complex developments that are needed and the overall development risk associated with that, and therefore reducing, we think, the development time required to get to a 2024 mission. We've emphasized reusability and sustainability from the very beginning for the 2024 mission and beyond to build in the elements of sustainability for the very first mission. And as was mentioned, also enable then upgrades or performance improvements over the long term to enable the long-term NASA goals for exploration, and also open up the lunar economy as we're beginning to see happen in LEO right now. You've seen in our press release the industry team that we bring. We've selected mostly small and mid-size companies across the U.S. And one international that have demonstrated experience with capability to move fast, be nimble in their development efforts, and deliver on time. Each of our team members were chosen for their recognized skills in technology and hardware systems, their ability to provide the support and hardware needed for the lander on the timeline required to make the 2024 mission successful. We also choose to partner with NASA in both collaboration and development as they outlined in the BAA. We're using NASA expertise in several technical areas, embedding them in our product teams, and we're also taking advantage of NASA's unique and capable test facilities for development and certification testing, allowing us to lower our overall development cost by not replicating capability that NASA already has. It's a challenging development and mission timeline to land by 2024, but we believe that our approach, our team, our collaboration with NASA make it an achievable goal. So let me stop there and turn it back over to you, Tony, and wait for further questions and discussion.
Okay. You also had I think you had the one in orbit. Did you want me to show that as well?
Yes, if you could pull that, that'd be great.
Yeah, it's up too. And this is what you're working on for getting the lander down. Is that correct?
That's correct. Yeah, that's the configuration that we have to come out of NRHO to start our descent to the surface. And then partway down, we'll drop those fuel tanks that you see on the ends of the lander and then take the central element all the way to the surface, and then that's the element that comes back off the surface.
These don't look anything like that LEM we saw from the 60s, man. This is like really great. Okay. Okay, so let's see. Nicholas, you want to give it a shot here? And what tell me what you've got a lot.
Yes. Yeah, I guess I'm gonna win the award for most charts today. So apologize for that. I'll go through them real quick, and they all look really good. So
okay, I'm going to need to set
you won't give me too much
because of the last minute changes we had to make with the Zoom meeting. I'm going to need to set up your PowerPoint. So can I play the video first?
Yeah, absolutely. Please play the video while you're pulling the PowerPoint.
All right, so here comes a video. Oops.
Also, you're going to have to let me know when it's over because I can't see it.
Yeah, I know. Okay, where did it go?
Okay, and if that's if you're ready for the charts, if
yes.
you can.
I am now ready. You are
okay.
You are live with the charts.
Okay, so are you on? Go ahead to chart 2. So.
Oops. Hang on.
Okay.
I gotta go. Start again. All right. Now. All right. Chart 2 is up.
Okay. So Starship builds on really on the game-changing reusability that we've demonstrated with Falcon and takes it a pretty dramatic leap forward. Starship will be the world's first reusable space transportation system, and Starship is our solution for NASA's Human Landing System program. You can go to chart 3.
Okay.
And so as you can see here, Starship's capability is pretty astounding, even in comparison to Falcon Heavy, which is the most powerful launch vehicle in the world today. So at over 300 feet tall, 9 meters wide. I know I'm mixing English and metric there. Hopefully it doesn't throw anybody too much for a loop. And you can see with full reuse, including of the first stage, the first stage we call Super Heavy, and of the Starship vehicle, we can still lift well over 100 tons to LEO. Chart 4. So this chart just kind of breaks down the vehicle in terms of nomenclature. Starship is the second stage of the vehicle, and it also serves as the in-space stage, the lander, and the reentry vehicle. Super Heavy is the first stage booster for Starship, and then we commonly refer to the entire stack as Starship. So the entire Super Heavy Starship stack is Starship, kind of like what the protocol was for Space Shuttle. So in conjunction with Starship's very low unit cost per launch and really extraordinary lift capability, we also have on-orbit propellant transfer, which allows us to affordably take very, very large payloads to deep space destinations, including the surface of the Moon and Mars. Our iterative design approach has allowed us to start building very quickly. We were very much inspired by the Apollo program, where there were many, many flights of the Saturn V, as well as the Mercury and Gemini programs working up to the Apollo landings. We were very much inspired by the rapid progress that was made under that. And so the Starship development program is very much inspired by that. So you'll see, continue to see a lot of activity going on in South Texas as we build and test the Starship system. Chart 5, Starship is powered by Raptor, which is an advanced liquid rocket engine. It powers both the Starship vehicle, or the Starship second stage, if you will, and Super Heavy. Production's well underway. We've already built over 30 Raptor engines and have accumulated thousands of seconds of time in the test stand. And we've even flight tested Raptor with the Starhopper flight test that folks saw last year. Chart 6. So for the HLS mission, we have a lunar optimized Starship that can fly many times between the surface of the moon and lunar orbit without the flaps or heat shield that's required for Earth return. The very, very large habitable and storage volumes allow us to provide pretty robust crew accommodations, including airlocks for dust mitigation and more than ample cargo space for the HLS missions. Next chart, chart 7 now, you should see the Starship deploying some large pressurized rovers to the lunar surface. Just shows how highly configurable the Starship's payload volume is. This image shows a configuration optimized for transporting very large cargo elements. Chart 8. So we believe it's well within our reach to support a very large number of people living and doing research on the moon. So to put things in perspective, the space station is about 400 tons and it supports a crew of usually less than 10 people at a time. So to sustain a presence on the moon, especially for a large number of people, we need to be able to affordably deliver many hundreds of tons to the lunar surface. And that's what the Starship is designed for, to transport very large masses as well as people to other planetary destinations. So if you go to chart 9, we definitely believe we don't have to choose between the moon and Mars. Starship is designed for both. And we think if we're smart and diligent about how we go about it, we can build an outpost on the moon and a city on Mars, and we can make humanity interplanetary civilization. That's the reason why SpaceX exists, and our partnership with NASA under the Artemis program is part of that journey. So we're thrilled and thankful that NASA chose us to be part of the HLS program, and very thankful that you invited us to be part of this conversation today. That's all.
Okay, awesome. Well, so, all right, I'm sorry, I'm pushing a lot of buttons here. Okay, let me go back to this. Okay. All right. Where'd you guys go? I'm here, but you're not. Oh my. Okay, well, suddenly now that I've switched from the PowerPoint to back to this, I've lost the panel. So trying to get it back now, just momentarily. Okay, so we still have them on audio. I hope so. We will be. I'll be fixing this as we go along. But I want to remind everybody that you can interact with us in a variety of ways. You can tweet at us with the hashtag of Future in Space, and I'm also looking at the live chats on both the American Astronautical Society's YouTube page as well as the Deep Astronomy YouTube page as well, and I'll read out some questions that also we have for the general public here, or that were prepared first. So I'm going to read this one. This is a general question for each company, and let's start. We'll start again with John from Blue Origin. The question is, why did you go with the design that you have proposed, and what's your thinking on your particular architecture?
Sure. So thanks for the question. As I kind of mentioned, we have a group of very strong partners, and our first objective was to really leverage the heritage, the legacy, and not only that, but what they can design towards the future. So Lockheed Martin, with their experience in cruise systems and what they can bring to the AE, the ascent element, in combination with various aspects such as similarities in crew training for the Orion vehicle that we'll be docking with. That was a huge advantage of using Lockheed. As I mentioned, Blue's been working the descent element and portions of that technology for well over 3 years. And not only that, but our LOX hydrogen engine, our BE7 engine, is very important to us for that sustaining mission, the ability to produce fuel and oxidizer on the moon and be able to use that not only in the descent element, but kind of bring commonality to the transfer element as well, built by Lockheed, or built by Northrop Grumman, excuse me. So Northrop is bringing the experience that they've had on commercial crew, COTS, commercial on the CRS missions as well as COTS missions with Cygnus. And we are really leveraging experience as well as what can we push for the future and how can we integrate between all the elements. And then on top of it, because launch vehicles are a critical portion of this mission, especially getting to 2024, we really laid out the element structure that we could use multiple launch vehicles so that we could pick and choose between what is available and even help drive down costs by having the ability to pick different launch vehicles. So that was the key to why we went with this architecture. And I found your comment very interesting about it doesn't look like none of the offerings look like the lunar module. You know, my background, we have a lot of family members who worked on LEM at Grumman out of Bethpage. And what I like about our architecture with the national team is it utilizes a lot of the mission design that LEM made work great, but it also updates it to current NASA standards and also updates the technologies. So it's kind of like a continuation of what the country has done and what we've built in the past. And again, hopefully now that we're over 50 years from getting there, bring a truly updated vehicle that will allow us to get to the moon as quickly as possible, but also allow sustainable missions. And that's why we went with that architecture.
Yeah, I can't believe it's been 50 years, man. It's been great. So, I mean, that we're finally now getting back on track here. So, Robert, how about you? Why did you guys pick the design and elements that you guys chose?
Yeah, thank you for the question, Tony. And that's a great question. Again, obviously, our teams off and went and looked at that problem and came up with different approaches to it. But really, what was key to us is, again, taking the requirements and the goals that NASA set out in the BAA for both the 2024 and the 2026 and beyond missions for the sustainability missions. You know, we looked at all the past trade studies, right? We obviously studied Apollo and the LEM architecture and the many studies that have gone on in the time from that successful program to now, and really traded all of those options against the requirements. And then, as we've mentioned, the sustainability word, we just really feel like the sustainability part is key. You know, we don't want to build a lander that supports a 2024 mission only. We want to build a lander that supports the 2024 mission and then many, many missions afterwards. And we need to do that in an affordable and a sustainable way. And so we traded that dozens and dozens of times. And so as we started with those the older studies and concepts and began to rack and stack those and evaluate those against the requirements for today, we just continue to iterate the design and with new and innovative people and ideas and really thinking about the crew and how to support the crew and maximizing the crew's safety and accessibility to the surface of the moon to be able to do science and exploration and to work and live on the surface of the moon. We just really felt like it was important to get the crew module as close to the lunar surface as we could, again, to ease all the operations surrounding getting in and out of the crew module to the lunar surface and back in. And so as we began to do that, again, we started to move the pieces that are required for the architecture to make the lander successful and arrived at this configuration that we call the descent ascent element, which carries the crew module. And ultimately what we ended up with was kind of this workhorse architecture that could not only support the crew module and ferry the crew and the crew module to the surface of the moon, but then that same architecture can then support payload deliveries to the moon, rovers to the moon. We can support really any payload or any material or delivery that's required to the surface of the moon. So one of the things that's really unique, I think, about the architecture that we've come up with is that it does support the 2024 mission. But then you can see by basically pulling the crew module out and us supporting, like I said, a variety of other, it can be pure supplies, like I said, it could be a rover, anything that you can imagine, science instruments, power systems, they can all be ferried from the lunar orbit down to the surface of the moon under the decent ascent element architecture that we've got. So, like I said, it really just came down to taking a fresh look, bringing in some new ideas, racking and stacking against the criteria for performance and payload delivery and payload up mass off the surface of the moon, crew duration. Again, crew safety was paramount to us relative to the human missions, and this was the architecture that we came up with, and we think it's really unique and innovative. Again, the descent ascent element, as it comes off the surface of the moon and rendezvous back with Orion for the crew transfer back to Earth, our lander can stay in lunar orbit indefinitely as it waits for additional propellant to come, refuel the lander, and then perform a repeat mission down to the lunar surface. Or again, with a payload delivered for supplies or rover, we can dock to that, mate up, and then ferry that down to the surface as well. So
great. All right.
that's how we arrived at the architecture.
That's great. Thank you very much, Robert. I appreciate it. Listen, guys, I see your chats. You guys are asking awesome questions. I'm going to get to it. And do what, like what Raj is suggesting, or Gregorius, I mean, is suggesting. Use that big red question mark so I can see it easier. And we will get to your chat in just a minute. So go ahead, Nick. Tell us about SpaceX. SpaceX doesn't do much, these days. So I'm sure you guys are,
we're all bored.
Excited to get involved in something. So
yeah. So no, thanks. Appreciate the question,
Yeah.
and I really appreciate the thoughts of the other panelists as well. It's great to hear smart people coming at a problem and kind of coming up with different approaches to solve it. I think that's what competition's all about, and I think that's one of the great things about this program. Starship. So Starship is an architecture that's designed to do a lot of things, as I talked about during my presentation. Fundamentally, it's we believe the cornerstone of the space transportation system that we would offer to make life multiplanetary. So Starship works fairly well for the HLS mission. We did look at alternative architectures. We looked at multi-element architectures, but we really came back to the fact that Starship provided a lot of capability. It allows for a true public-private partnership because of the fact that it's such a multi-mission vehicle. We'll be using it for everything from satellite launches to, again, lunar missions and missions to Mars. So it was a capability that we were investing very heavily in, is a capability that we're investing very heavily in, very well along with development of the Raptor engine, with the production capability that we're building in Boca Chica, Texas. We will have the capability to produce a very large number of Starship vehicles very quickly in kind of a mass production type approach. That, in conjunction with the reusability of the vehicle, allows for a very, very low marginal cost per mission. So we think Starship has a lot to offer for this mission, the ability to take the crew back and forth from the lunar surface, but also, again, transport those very extraordinarily large cargo numbers that I was talking about earlier, not just tens of tons, but ultimately hundreds of tons affordably to the surface of the moon. And so for us, the decision turned out to be pretty simple. We felt like Starship made the most sense. It allowed for the best true public-private partnership with NASA. And we also like the fact that it really advances our nation's posture in terms of reaching Mars. So
okay,
that was the thought process there.
Thank you. Okay, Amanda Hernandez wants to know, are all teams planning on reserving some space for commercial payload sales? You guys got any room for commercial stuff?
Yeah, so at Origin. Oh, I'm sorry. Go ahead.
Yeah, I probably should organize this better. We'll start with our top down. How about we'll start with Blue Origin. Go ahead, John.
Sure. So yes, we do. And not only that, we have multiple configurations. So as I mentioned, the 2023 mission, we are launching the descent element and transfer element as a demonstrator to go to the moon. That has the capability of carrying some commercial payloads in agreement with NASA. But our architecture is specifically designed to either have carry-ons that, whether we work with our partners in NASA to utilize, or if we use different configurations for an entire cargo lander. That's specifically why we came at this this approach for our architecture.
Okay, go ahead, Bob or Robert. I'm not sure if which one
Sure.
you prefer, so I better stick with Robert.
I'll stick with Robert. That's fine. Thanks. Yeah, no, we do as well, right? So we've got space set aside for commercial payloads for the initial mission. We actually see the commercialization aspect as playing a key role in the overall sustainability of the architecture, and as I stated earlier, the lunar economy. And so we've already been reaching out to commercial partners, international partners, and identifying opportunities for future lunar missions. And so we'll be working that very aggressively for the first mission and beyond.
Okay. And Nicholas, how about you? What, you got any room for commercial payloads?
We got lots of room. But you know, we do commercialization is something that's is very important to us. As a matter of fact, we already have a commercial mission, a human flight around the moon called Dear Moon. That's something we're very, very excited about. So I think you're going to see a lot of new commercial opportunities with Starship architecture. We're really excited about it.
Great. Okay. Parker Huntington wants to know, this one I think is for you, Nick. What is the status of the high-low thruster? Let me start that again. What is the status of the high-low thrust lunar descent engines on Starship and the propulsion? Oh, and the propulsion on the Dynetics lander. So that's for both of you. Shall I read it again?
Okay, I think I understand what the question is. Yeah. For my part. I'll go ahead and go first.
Okay.
I think the question's about for the terminal descent of Starship, a few tens of meters before we touch down on the lunar surface. We actually use a high thrust RCS system. So that we don't impinge on the surface of the moon with the high thrust Raptor engines. So I think that's what the person is asking about. The thrusters that are planned there have a lot of heritage in the actual Raptor design itself. It uses the same methane and oxygen propellants as Raptor. So there's a lot of commonality there. Mm-hmm. And we're going to be ramping up some very rapid testing activities coming up here in the coming year. So I think you'll be hearing more about that as time goes on.
Great. Okay. Robert, what's the status of your descent engines on the lunar lander? Oh, he's gone. Where'd he go? Uh-oh. Or his video got turned off, one or the other. Plus he's muted. Oh man. Okay. Well, we'll come. Hopefully, when he comes back, we will finish that question. Kenneth Hornman wants to know: are all three of these going to fly, or is a down select coming? What's going to be the status here with the three of you being selected, and then who gets to land? Are all three of you going to be able to build your fly these or not? John, you want to start?
Sure. So the way the program's currently structured, between the initial mission, currently called Option A, for the first landing on 2024, there will be a down select. Whether it's one or two providers is to be determined. Yeah. But all three are in the mix for sustaining missions. And that's what's great about, I really like to see the differences in the designs between all three companies that were selected, all three teams, because it does allow us to all prove out different technologies and different approaches. And the competitive nature, that's what we're really about for doing this. That will keep the tempo going. That will keep things moving in a proper direction. And I think about even in the commercial airline space, there isn't one aircraft that satisfies every route, every mission. So the ability to give NASA, the country, and even the world the ability to choose from different designs is interesting and is part of the competition. And that's why, again, not only do we have the ability to land humans on the moon, but we are looking to land cargo on the moon so we can sustain operations on the lunar surface for the long term.
Yeah, that's a really good point. And I also want to bring up something that I want to get your thoughts on. When I was at the last American Astronautical Society, I think it was the Glenn Symposium. It might have been Von Braun. I can't remember. But by the way, the Glenn Symposium's coming up in July. You can register for it at their website, AAS.org. So the NASA administrator that came and gave a talk said that one of the things that NASA is trying, it wasn't the NASA administrator, it was an administrator. I don't recall what her position was, but she made the point that NASA is now trying to create a space economy where they right now are the demand. Right now, NASA is saying to private companies, we would like to put a human in orbit, for example, and we don't care how you do it, or at least we're not going to dictate to you how you do it, but they want to be a customer instead of planning every single design on this. And I actually think this is a smart idea, because by creating a space economy, you're not only generating right now NASA is the demand and you guys are the supply, but the idea is to have other people, come in and to sort of not just be a one customer economy, and NASA's hoping others will jump in and do that. What do you think, and I'll start with you, Nicholas, what do you think of that approach that NASA is taking? This creating of a space economy.
Yeah, I think it's hugely important for sustainability, and I'm sure everybody would agree. I think the key factor, though, is that really to enable new, really a rapid growth of the space economy and brand new applications in space that will allow that, we've got to dramatically reduce the cost of access to space. Yeah. And it can't not just, it can't just be a few percent. It can't be 10%. It can't be 50%. I mean, we're talking about orders of magnitude in order to really enable the type of growth that we would love to see in space, and in order to sustain an interplanetary civilization, which is, I think, what really will be that massive expansion of the global economy, is when it becomes an interplanetary economy. So I think NASA is absolutely right to be focused on that. I think the key figure of merit there is dramatically lowering the cost of access to space.
Okay. John, do you have any thoughts on that?
Yeah, first, I completely agree with the need to lower the cost for access to space.
It seems to be working, doesn't it? It seems to be actually working.
Definitely.
Yeah.
It definitely does. And as you can see, how it's starting to displace certain business models on orbit regarding communication, satellites, Earth imaging, those kind of approaches. What I really enjoy about the NASA approach, and this was difficult, but under 15 years ago, NASA originally came out with COTS, and they had two competitors working that program to deliver cargo to the International Space Station. So they're allowing commercial space to have that toehold in cargo to low Earth orbit, then to crew to low Earth orbit. Now the moon is becoming part of that. And as we establish commercial providers, because I do see it as being many providers, but to the moon, that allows NASA to focus on one of the things they do best, which is Mars and beyond, continuing to push the envelope, and commercial space follows there. And when I say commercial space follows, it's even building LEO infrastructure, commercial space stations, commercial moon bases. This is a long-term effort. And I've mentioned this in the past. This follows the model that government established almost 100 years ago, a little less than that, but about airmail contracts with commercial airlines. Airmail was cargo. It was not profitable to fly an airplane at the time between some routes, southern Florida to Cuba and those kind of routes. But those were the toeholds that then allowed large commercial airlines and then airliners to grow from. And it's a business model that is continuing on into space. And that's what really excites us.
Okay, here this is from the Bucket Mouse, and it's for SpaceX. Is there any analysis on if the lunar regolith can support the weight of the lander?
That's a great question. And the answer to the question is yes, but we're not done yet. We have a partnership with the Kennedy Space Center, who has with NASA at the Kennedy Space Center, who have some great expertise in the properties of the lunar regolith and how things like the plumes from engines and the lunar regolith interact. So we do have a lot of data from Apollo, and we're fairly certain that with the way that we've sized the landing legs and the foot pads, that we're not going to have any issues there. But we're certainly remaining curious and researching the topic and learning everything we can.
Okay, Sir Hot, I'm just getting to the questions because there's so many. Sir Hot Demergil is asking, do any of the teams use a fatigued landing gear mechanism to use the mechanical energy of broken joints to save fuel on propulsive landing? And in parentheses, he's got Innovative Design Award winner for landing gear systems.
Yeah, so for Blue Origin, our landing gear design, which we are right now creating some demonstrations around, we are trying to gauge towards reusability as well. So between the idea of fatigue usage, crushable materials, those kind of things, those don't lend themselves, they may or may not honestly lend themselves to reusability. And if it's a simple gain to get there, then we would probably go with a reusable design first.
Okay. Nick, any comment on that?
No, I think similar. The crushable systems, certainly have some advantages from a simplicity perspective, but they are limiting from a reusability perspective.
Okay. Hans Milligan is going, that rocket is a monster. Presumably you're talking about Starship. Do you make a structure that supports the weight of the rocket? I'm not quite sure. You mean once it's on the moon?
Well, I guess the answer to that question has to be yes.
Yeah. Yeah, I would. Yeah, you're not going to make a structure to support it. We're just going
otherwise we're in real trouble. But yeah, I mean, obviously if you're talking about me, the pad structure, the launch mount and things like that are all designed for the fueled mass of the vehicle. It's pretty much engineering 101 is to step through all the operations and look at your masses and the dynamics and make sure everything's sized appropriately.
Yeah, we can't have a discussion about building a lunar lander without this one. Gregorius wants to know, everyone's kept avoiding this question, but can you talk about the space toilet solution? Anybody want to comment on their space toilets?
Let Nick go.
Let's let Nick go. Nick, you do it, man. Come on, man. What kind of toilet do you have?
I am unfortunately I'm not the toilet guy. I mean, we'll have them,
right?
Yeah, we'll have them. Hey, look, it's that's the problem. I've talked to schools and things like that. That's what all the kids want to know about. Starship is going to be designed to keep, quite a few people alive and comfortable on long journeys to Mars and other deep space destinations. So all of those basic necessities are definitely things that will be planned for. I suppose there's probably some design considerations, for a system that has to work in both zero and partial gravity. Interesting question. I'm sure there's a lot more work to be done. Certainly not a system you want to have break on you.
Right. Yeah. To Gregorius' question, that's again one of those things that we as a national team, having the experience with Orion, and SpaceX now has with Crew Dragon as well. We do have experience in these kind of human factors, human accommodations. So that's one of those things that hopefully we don't have to develop from scratch. They will be proven out before we incorporate them into the vehicles.
Okay, let me just read Clive Neal's comment. He's saying that the lunar regolith will support Starship, but the dust plume generated by takeoff and landing will sandblast anything around it unless contained unless contained launch landing pads are engineered. So there's a bit of
Yeah, and I just
Clive.
just to comment there on Clive's comment. That's partially, I think, what the question was asking about earlier. Again,
Yeah.
we don't actually land on Raptors in the HLS concept. Although we agree with Clive that long term, when you're ascending and reascending from a base or another kind of location, having an engineered surface is very helpful.
Yeah. John Suffolk's asking, can the SLS be adapted so that the first stage can be reused? He said he asked, sorry if that's already been answered, but no, we haven't answered that yet, John. Can the SLS be adapted in any way to be reusable, or is it strictly a one-shot use? Anybody?
I don't think that's really a question for us.
Yeah, you guys working on
I mean,
that.
I guess I would point out that the boosters for SLS came from shuttle and they were reused on shuttle. So
Yeah.
there's probably at least some partially reusability that you could figure out there. But from what has been said publicly, I don't think that's part of the current plan for SLS.
Everything I've learned about it, it says it's not going to be reusable. So Michael Barker wants to know, for all teams, what are your plans for hazard detection in the final seconds before landing? What are your plans?
So for Blue Origin, we have a sensor group that is actually right now developing that strategy as part of the base period. We will be able to fly portions of these sensors on our new Shepard vehicle prior to going into the next phase. So we will be able to demonstrate some of those out of our West Texas facility. And the nice thing about having that vehicle, and again, just like SpaceX does, we could fly multiple packages together to not only trade performance, but also trade cost, availability, etc. So this year is a very exciting year for the national team because we are moving forward on a lot of different technologies and a lot of different work that has been in the pipeline for some time, and it will be demonstrated this year to show our maturity going into the next phase.
Okay, I apologize. Robert's been sitting in the waiting room. But they changed Zoom, and now I've got to admit people into the meeting, and I'm not used to that. Here he is. I'm sorry, Robert. You were sitting in there, and I just assumed you were going to pop back in. And we've had
no worries, Tony.
I really apologize.
While I was gone. Yeah.
Okay, so thank you, Jim. Jim's like, Tony, can you let Robert back in? He's in the chat there. So there we were asking earlier, there was a question for you. I'm going to try and find it, but first let me get another question out. Future Martian 97 wants to know, will Lunar Starship use the same landing thrusters for liftoff, or will you use the Raptors?
Yes, we'll use the same thrusters for liftoff.
Okay. Oh, I was hoping for a longer answer. Okay, I'll look for that question.
That's okay. Well, I can also add on the last question, just like John said, in terms of landing sensors, and I would bet Robert probably has something to chime in there too. All of the lunar landing systems will need some sort of capability to detect hazards on the lunar surface. The size hazards, and the specifics of slope and things like that will probably change depending on the lander design. So we will, with Starship, have the ability to test out our propulsive landing capabilities many times via Earth landings, where you have to deal with winds and a lot of other things. And then, of course, for the lunar specifics, we'll have cameras and onboard instrument suites for what you've probably heard referred to as terrain relative navigation, where the vehicle is comparing what it's seeing with its instruments and sensors to intelligence gathered from systems like the Lunar Reconnaissance Orbiter to effect a safe landing on the surface of the moon.
Great, thank you. I found the question, Robert. For Dynetics, the question was from James Horton, and he wants to know: was storable propellants considered for your architecture?
Now, that's a great question, and it absolutely was. Again, as some of the other teams have mentioned, we've been working on our lander concept and approach for more than a year as well, and done a whole series of trade studies dating back to last year. We looked at all the propulsion options. We looked at all the available engines. We looked at all the available fuels and oxidizers that were available to us. and really traded all those against each other, looking at the mission performance requirements, again, to be able to support the crew, support mass down to the surface and getting back off. And what we found in our trades is that where the current storables, engines, technology were, and the overall performance, that we just didn't get the performance that we were needing to close the mission based on what was currently available. And when we looked at doing additional development work around storables, we just really felt like that it was better to invest that time and money into an architecture, a propulsion architecture that was more sustainable for the long term. And that's how we down selected to a LOX methane approach.
Okay, great. Thank you. This one's from Ulysses Eduardo Nunez Garzon, and I'm going to lump both of his questions together because they have to do with the selection process. He goes, what does the rest of the selection process look like, and when is your next major review, and what are your deliverables? So give us a sense of what you're preparing for in this competition. What's the next big stage? Are you guys subject to a review? Do you have to pass certain milestones? Let's start with you, John.
So yes, we have a number of milestones here through right now February of 2021. Some that were given to NASA or from NASA directly as part of the proposal, and then some that we propose separately to show the maturity of our design as we progress over the next 10 months. So there's a number. As I mentioned, we'll also be showing some demonstrations of actual hardware. I should mention also to the BE7, some of the questions on engines. We'll have our BE7 in the test stands in Marshall this year, demonstrating some portions of those operating, as well as components of our turbo pumps in manufacture. So the BE7 is very, it's as I mentioned, LOX hydrogen engine for us that allows reusability without a lot of refurbishment required, especially because we will be in the lunar environment for multiple missions and sustaining missions. So that's kind of a microcosm, if you will, of some of the work that we'll be doing, not only in this space period, but beyond. A lot of it is right now design reviews and that kind of thing.
Yeah, is that about right, guys? You guys, Robert and Nick, you got anything to add?
Yeah, very similar to that. You know, we've got design reviews throughout this period. There's 2 major reviews with NASA that NASA scheduled as part of the BAA, and so we'll be going through a very similar process.
Great. Okay, and I assume Nick, same thing.
Yeah, very similar. We are of course very focused on the development and production efforts in South Texas. So we also we expect progress there as we're building and maturing the Starship system will be very important for the decision process moving forward.
Yeah, well, looking at the three offerings, man, this is like a feast. I'd hate to be the one having to choose this, but like they all look amazing and great. So I'm going to ask James Dugan's question because I'm wondering the same thing, and we can't have this conversation without asking it. Be honest, okay? Just to give us your opinion. What are the chances of us getting boots on the moon by 2024, as stated by in our goals? Are we going to do this, guys, by 2024? Just give us your opinion. You don't gotta, go out on a limb. Tell us what you think. Nick, go on. Do it, man. You can do it.
Yes.
What else did I expect? Okay, how about you, John?
No, I think the thing to look out for there is it's certainly an aggressive timeline compared to what other systems, at least a lot of space systems have been developed in. We have confidence from the amount of time it took us to develop Falcon, the amount of time that we've been able to, the rapid iteration that we've been able to achieve with other systems like our propulsion systems. We think this is very doable. It's absolutely going to require a partnership with NASA. It's actually absolutely going to require a commitment from everybody to stay focused on the things that are the most important to reaching that goal. And I think, chief among that is making real progress with hardware, not getting too mired down into to some of the specifics of things that maybe are are not critical to that. So I think what I would encourage everybody to look for is for hardware progress. For you want to see engines firing, you want to see stuff being built. That's what's really going to give you a good indication if we're going to be able to get this done by 2024.
Yeah. Okay. Anybody else want to comment?
Yeah, I'd agree. It's an aggressive, but it's an achievable goal. And NASA's been a good partner with this as far as from when we started, how can we bring the schedule to the left? We need to ensure with NASA that our requirements are locked down, the design and construction standards that we are working towards are locked down so we can start building hardware, just like what Nick said. But that's exactly why we chose this architecture. We now have 3 partners plus Draper across all the partners working together to get parallel efforts to get to the moon as quickly. So yes, challenging, but NASA's working very hard to move that schedule to the left. And we've done a lot of work internally to Blue over these years, as well as with our partners, to get going on that and really build hardware and really show that this is a mature approach.
Are you confident also, Robert?
I am, Tony. And again, I like what John said. NASA has really started this process with a firm, a real commitment to lock down requirements and to review these design and construction standards to get a common understanding as to what that looks like going forward. As Nick pointed out, it's a very aggressive schedule, but one of the things that we've done is to minimize the development that's required across the lander. Try to use as much off-the-shelf or previously demonstrated hardware, similar to hardware, and minimizing the development. We can accelerate the schedule, and so it definitely is an achievable goal.
Okay. Shmoo wants to know, just a couple questions. I know you guys got to go. Shmoo wants to know, for Dynetics, can the lander, for Dynetics, can it be used for a mobile base or a type of moon taxi? Can it be used for any of those things? Oh, he died. He went away again.
No, I'm here.
Oh, good. Okay.
Yeah, so could you repeat that, Tony?
Yes. Can the lander be used as a mobile base or some kind of taxi?
Absolutely. So again, the crew module can be outfitted in a variety of different ways to support a variety of different missions. Again, the supportability on the surface is going to depend on potentially pre and placed assets, or as pre and placed assets are made available, and so commodities are available for the crew to stay for longer term. There's no reason why our lander couldn't support a long duration mission, or for a variety of different things. We've even looked at options where we could potentially mobilize our lander once on the surface. So a lot of versatility there. Not all those details are worked out, but there's certainly a lot of options there, a lot of flexibility for a variety of different missions.
Okay, great. Let me get Future Martian 97's question in real quick for everyone. Will all 3 landers have cameras on them to live stream the landing?
Absolutely.
Anybody not doing cameras?
Yes.
I'm not going to ask SpaceX. Of course, they're going to have some cameras on there. Of course they will. Let's see. Okay, I think I better let you guys go, but I don't want to. There's so many great questions. Nick Johnson, just real quick, wants to know, how does Starship avoid tipping over upon landing on the uneven lunar surface? Can you answer that one, Nick?
Yeah, that's a really good question. The center of gravity when you land with Starship is actually probably a bit lower than it might look like from the pictures, just from seeing the outer mold line. The propellant tanks are in the bottom of the vehicle, and of course the engines are fairly massive as well. It also has a very wide base. The diameter of Starship is 9 meters, so that works together with you, along with some other capabilities that we have relative to leveling. And some anti-tip measures that we can kind of take advantage of. So Starship's actually quite robust to a pretty wide variety of surface features and slopes. So it is something that we looked very hard at and have talked about quite a bit. But we definitely have solutions there.
Okay, thank you. I'm gonna end this stream with Vibe's comment, and I want to thank. I'm sorry if I didn't get to all of your questions. Thank you for being so engaged in this chat. There's been so many of you wanting to ask some really great questions, but we only have so much time with these great guys. So I just want to leave this with Vibe's comment, who's saying it's just great to see a cross-company stream like this, all in the same team after all. And so, what is the atmosphere like among you guys? Are you all collegial? Are you all working together? Is there any kind of, friendly competition? Give us a sense of how you guys are together as a team working on this. 3 companies. John, go for it, man. Can you comment? Nobody? Robert?
Yeah, I'll jump in there and just say, obviously with the travel restrictions, we haven't actually been face to face yet. But yeah, I think collegial competition is good. We've talked about, we're in a competition for each other, but we all are passionate about the mission that we're about, and, not just supporting NASA's missions and goals, but again, seeing the exploration and long-term sustainability of the lunar economy. So, I think jointly we want to be successful there. I mean, who doesn't want to see America have the access not only to LEO but also to the lunar environment? And we certainly want to be there. We want to be there first, but we want America to be there first, or to go back first.
Yeah.
So, support everybody.
I think that's definitely true. I like the sports analogy. When we're out on the field, we all compete hard, but we all know that we're passionate about the same thing. And at the end of the day, we take our jerseys off and are happy to grab a drink together or a sandwich and talk. The space community is very small, and we're all passionate about the same thing, and we're all rooting for each other. So that being said, when it comes to competing, and I think this is actually very much to the government's benefit, as I think everybody on the panel has talked about, when it comes to competing, we absolutely want to win. And we think that's what makes the whole industry better.
Yeah, and just to reiterate, I do think it's very, very friendly. It is competition. As you mentioned, it's for the country and for the world. And also it's actually to inspire the next generation of engineers, of scientists, of mathematicians across the board, artists included. The fact that we are all competing against each other, but at the same time trying to achieve the same goal, will result in a space economy and a result for humanity that we have finally been reading about in science fiction, but will actually become science fact finally.
I know, man. The space times, they are a changing. It really is a new era, and I applaud NASA's effort to get this space economy rolling this way. I think it's absolutely the right thing to do. Well, I'm going to stop the stream here, guys. I want to thank my guests, John Couluris. He's from Blue Origin. He's the HLS program manager there. Also, Robert Wright from Dynetics. He's the deputy division manager there as well. So thank you both for joining us, as well as Nicholas Cummings. He's the director of Civil Advanced Space Systems at SpaceX. You guys are busy people. I know you got a lot to do, but I want to thank you all very much for taking time out to share with everybody what you're doing and getting us going on this really exciting adventure. So Godspeed to all of you. I'm just glad I don't have to pick one. So it's everything. But I hope it all goes well for all of you. And I think these are exciting times. So thank you all very much.
Thank you very much, Tony. Thanks for having us on.
You're very welcome. Okay,
Bye,
so
everyone.
Yep, and you guys can just hang out or hang up on the Zoom meeting if you want to. I'll go ahead and say goodbye to everybody. All right, thank you guys for dealing with the technical issues at the top of this. We very last minute switched from what we were going to use for teleconferencing to Zoom, and I had to hurry up and get that set up. So I thank you for your patience in the late stream. This stream has been brought to you by the American Astronautical Society series of Future in Space Hangouts. It is sponsored both by Blue Origin and Dynetics. I want to thank both of them for supporting this hangout, without which they do not come to you. So if you like this hangout, please share it with people. Please give the thing give us a thumbs up. Also, the Glenn Symposium is coming up in July. You can register for that at the AAS website. The link is in the description box of this video, and it will be a virtual event. I'll be involved, and hopefully we will be able to present this to people who ordinarily don't get to go to the Glenn Symposium. So that'll be coming up in July. Please register. Also consider becoming a member of the American Astronautical Society, because they're great. This is awesome stuff. And if you want to keep it coming, support these guys. And they also have we are streaming this also live on their YouTube channel. So please subscribe to them as well and follow them on Facebook. Thank you all so much for watching. And on behalf of the American Astronautical Society, my name is Tony Darnell. You guys are awesome. Keep looking. Well, that sounded like I was dying. Let me try that again. Thank you all for watching. And as always, keep looking up.